Hello everyone, and welcome to today's webinar on optimizing your infrastructure with Dell EMC and Splunk. In today's session, we're excited to have Jenny Hollfelder from the Splunk team, along with Cory Minton and Dean Jackson from Dell EMC presenting. For today's agenda, Jenny will start with a brief Splunk overview and talk about our partnership with Dell EMC. After that, Cory will talk about Dell EMC infrastructure for Splunk Enterprise, sharing best practices and lessons learned. After that, Dean will demo some Dell EMC's apps for Splunk, and then we'll finish with around 15 minutes for Q&A. Before we get started, our legal department has asked me to show you this slide with the usual disclaimers. Also, if you have any questions during today's presentation, please leave them in the Q&A box in WebEx, selecting the All Panelists drop-down option. All lines will remain muted today. With that, Jenny, the floor is yours.
All right, thanks, Ishan. Hi, everyone. I'm Jenny Hollfelder, and I'm a sales engineer at Splunk. I'm also the technical lead for the partnership with Dell EMC. Today, I'm pleased to be joined by two very talented folks, Cory Minton and Dean Jackson. Cory has given numerous presentations on Splunk and has presented at Splunk's annual user conference, .conf, not only once, but twice. He also leads the Splunk Ninja team at Dell EMC, and he'll tell you more about that team and what they do in just a few minutes. Dean is one of the ninjas on Cory's team and has the very cool distinction of having the most Splunk certifications on the team, a whopping 6, including Splunk Architect, Splunk Certified Consultant, and ITSI Specialist. In addition, Dean wrote the Dell EMC VNX app for Splunk, which you can find on Splunkbase, and we'll learn more about when Dean demos it and other Dell EMC apps for Splunk later in the presentation. Dean, Cory, it's truly a pleasure, and thank you for joining us. All right. So before I jump into the presentation, I wanted to share a little bit about myself. I joined Splunk about a year ago after working at a couple of startups. My background is in Linux systems administration, and the bulk of my career was spent working for a large national lab where my team was responsible for over 2,500 Linux and desktops and servers, and we also maintained several critical applications and services that were used site-wide. I discovered Splunk at a LISA conference back in 2007, and after downloading and giving Splunk a try, I knew there was no way I'd go back to my homegrown scripts and other open-source tools I'd been using to try and gain insight into my environment. By the time I left that job in 2013, Splunk had become the gold standard for IT operational intelligence and was also being used extensively for security and other use cases within the organization. Splunk was and still is a game changer. And in the first few minutes of this presentation, I'm going to provide those new to Splunk with a quick overview of what Splunk is, how it works, and the value it delivers to our customers. I'll then speak briefly about the Dell EMC Splunk partnership and what it means for you. At that point, I'll turn things over to Cory to go into more detail about Dell EMC for Splunk Enterprise. I thought I'd start by sharing the driving force behind every product and solution that Splunk as a company develops for our customers. Our mission at Splunk is to make machine data accessible, usable, and valuable to everyone in the business. This includes the IT administrators who are responsible for keeping your business up and running, the security team who is responsible for keeping your networks and data safe and secure, the application development teams that are responsible for delivering apps that function as expected, and the executive who regularly needs information from multiple sources in order to make informed, data-driven decisions that affect the business. Machine data contains the answer to many of the questions that are critical to these individuals being able to perform their job, and in order to extract these answers, you need Splunk. Splunk is a leading platform for machine data analytics with over 10,000 organizations and 80 of the Fortune 100 using Splunk to derive business value from their machine data. Splunk software reliably collects and indexes all the streaming data from IT systems, technology devices, and the Internet of Things in real time, tens of thousands of sources in unpredictable formats and types. And because Splunk supports something we call schema on the fly, it means you don't need to know the format of your data before you send it to Splunk. Simply point your data at Splunk or configure Splunk to collect data from a remote source, and Splunk will extract fields and be able to correlate across multiple source types and formats at search time. If the format of your data changes or you want to change how field extractions are performed, you can do that on the fly without the need to re-index your data. Once you get your data into Splunk, you can quickly and easily search, perform statistics and analysis of the data, correlate across multiple data sources and formats, and create reports and powerful dashboards that provide instant insight and also enable the ability to drill down for further details as needed. Splunk scales from tens of gigabytes per day to hundreds of terabytes per day and supports both distributed and cluster deployments for high availability and performance. Some common examples of use cases for Splunk include IT operations, security compliance and fraud, business analytics, application delivery, and Internet of Things. The key takeaway is that the Splunk software platform is what makes it possible for machine data to be accessible, usable, and valuable to everyone in the business. Splunk enables you to extract unprecedented insight and operational intelligence from machine data collected from your environment. So at this point, you may be thinking, okay, that sounds great. Where does Dell EMC fit into the picture? Well, unless you're going to run Splunk in the cloud, you need infrastructure for your deployment. And figuring out exactly what to purchase can be a bit tricky. Splunk provides general sizing guidance, which is an excellent starting point. However, still leaves a lot of configuration decisions up to the customer. And because most customers want to know that whatever they're buying is going to work and work well, the customers often look to us to help them with that decision. What we've done to help our customers is we've enabled partners who want to sell their infrastructure for Splunk to create reference architectures that are in compliance with Splunk's general sizing guidance, so they in turn can provide that to their customers to help them with their buying decisions. Dell EMC is an elite Splunk partner, which means we've gone a step further and worked with them to create and jointly test and assess the performance of Splunk Enterprise on their hardware. This has allowed us to come up with Splunk-validated configurations for Dell EMC infrastructure that we know meet or exceed the performance of Splunk's documented reference hardware. The Splunk-validated configurations range from 50 gigabytes per day to 1 terabyte per day. In real life, I've seen customers deploy upwards of 4 terabytes per day by scaling out the Dell EMC infrastructure described in one of the Dell EMC solution guides. And because of the rapid time to deployment that the Dell EMC solution provides, combined with the insight and value Splunk Enterprise delivers, that customer is already looking to onboard more data to accommodate additional use cases. This is the Dell EMC partner page that can be accessed from splunk.com/DellEMC and has more details about the partnership, including the solution guides and reference architectures I mentioned. Speaking from experience, the response from our customers when they see our joint commitment to their success has been overwhelmingly positive. And that is just one of the ways our customers benefit from the Dell EMC Splunk partnership. With that, I'd like to turn things over to Cory, who will be sharing more goodness about what we've been working on and how Dell EMC and Splunk are helping our customers achieve operational intelligence and performance at scale.
Hey, Jenny, thank you so much. Great introduction. My name is Cory Minton. Again, I'm a principal systems engineer for EMC, Dell EMC, and I'm super excited to talk about the great things that we're helping our Splunk customers accomplish. We as an organization realize that based on the value propositions that Splunk that has for customers and that Jenny so well articulated, Splunk is becoming a critical application for many organizations around the world. And when any application becomes critical, a few things start to happen. One, the size of the deployments starts to increase very rapidly, and we're seeing that very much with Splunk. Splunk starts, part of the value is it can start as small as running on your laptop to it can run on thousands of machines. And we are seeing customers adopt Splunk for a variety of use cases, expanding those size of deployments very quickly. As any application becomes critical, search performance or performance of that application becomes highly important. We also see availability and reliability becoming a crucial consideration. And anytime you have a critical application, enterprise IT organizations typically want to control the infrastructure and the standards, the underlying standards being used. And so we're seeing a bunch of this stuff where Splunk is a critical application, enterprise IT is getting involved, and efficiency is becoming a very important factor. And these critical needs are things that Dell EMC has helped customers deal with for many, many years around critical apps. So Dell EMC provides scalable and efficient enterprise-class solutions for deploying Splunk. Now, many customers will ask us, and as they start to go down their evolution with Splunk, they'll say, well, why does Splunk start to grow and how does it grow? Well, we see Splunk growing in a couple of key areas that impact infrastructure very significantly. First, around performance. The things that may grow or that may cause Splunk performance to need to increase are things like increased ingestion. As you ingest more data, you need more infrastructure performance to handle the indexing and searching of that data. As you apply new use cases, search performance becomes very interesting. As you add users, you need more performance to support the additional users. And then any of the big applications like enterprise security, machine learning, user behavior analytics, those require some additional performance from your underlying infrastructure that we very clearly need to understand. Then from a capacity perspective, the Splunk environments grow from things like additional ingest, right? As you add more data, if your retention periods stay the same, you're going to need more capacity from an infrastructure perspective. Similarly, if you increase your retention periods for those indexes, then you're clearly going to have a capacity need. Also, when you enable things like high availability indexer clustering, it can create additional storage capacity consumption, which will cause your environment to grow. And then those big apps, similarly, they need performance. They also can need capacity when you turn on things like data model acceleration. So we see Splunk growing in a number of very interesting ways. Now, most customers, when they start with Splunk and they start using Splunk, it's pretty simple. They start with it by deploying on their laptop or on a small virtual machine, and Splunk runs nicely on a server on a laptop, right? You take a compute, some network and storage, and you can deploy Splunk very easily as a single machine. But usually customers don't stay with a single machine very long because they realize the value of Splunk. So they end up starting to deploy it on many, many machines. And when you deploy it in a traditional server environment, you have tightly coupled the performance and the capacity, meaning as you add a server, yes, you add performance from a CPU and memory perspective, but you're also adding a symmetric amount of storage to that environment. But the challenging thing is we see a lot of customers in real-world deployments not having this perfectly linear need. Things like enterprise security or user behavior analytics and ITSI can drive up the performance requirements for infrastructure to support Splunk, although they may not drive a huge amount of capacity changes to a customer's requirements. And then if you have things like higher term retention, you may find out that our longer term retention for compliance that you need more capacity, but you don't need more performance from a compute perspective. So this tight coupling can be challenging to respond to the real world requirements because we see customers kind of being all over the map in terms of how their Splunk deployment evolves. And we really want to help figure out a way to deploy infrastructure that allows you to be flexible to respond to the demands at the right time with the right infrastructure investment. Another way to think about this is there is a powerful idea of decoupling compute from storage in Splunk. We've seen this in other critical applications over the years, and it's true in Splunk as well. Now, I know this is a little bit of an eye chart, but if you think the bottom, the x-axis here is retention from 0 to 10 years, and the y-axis is your ingest rate from 0 to 10 terabytes per day. And in the red, basically what we're showing is the areas where if you're deployed on a traditional direct attached storage in a server model, you may be investing in resources at the wrong time to respond to the need. So if you're doing more than 200 gigs a day, or you're doing more than 6 months retention and you're still using only the storage in a server, you may be buying too many servers purely for the purpose of compute, and you really should consider decoupling compute from storage. Thankfully, Splunk gives us a very simple way, based on their index architecture, to decouple compute from storage in a very neat manner. The first of which is everybody probably understands that Splunk, as it writes data in, it collects data into a hot bucket. This is really the storage location of that most active data, the most recent data. As that data fills up in a configurable manner, it drops the data down to warm. And this hot and warm bucket combination is what Splunk refers to as home path. Then as the data ages out of warm, it goes into a cold path. And what Splunk has done is in this architecture, they allow you to invest in infrastructure for the right need. So in hot and warm, that's where most of your searches are going to happen. And Splunk generally recommends flash technologies from a storage perspective to accelerate performance of hot and warm. However, for cold, you're keeping data for longer-term retention, likely for compliance reasons, likely for those searches that aren't happening as often. So really the idea there is to optimize your storage cost by using things like network-attached storage as a way to optimize cost per terabyte rather than trying to optimize for performance. Now, Splunk does give you the ability to do things like frozen, which takes data out of the searchable path, but may allow you to even further lower the cost of storing data for very long-term retention. However, we at Dell EMC generally argue that we can make cold volumes so large and so simple to manage that you can actually derive value from all of your data without having to leverage that frozen functionality. Now, the way we do this is Dell EMC has some very unique value propositions for Splunk. The first of which is that we offer optimized shared storage and tiering. So all-flash technologies are very important in terms of data center modernization because they deliver really groundbreaking performance, and the costs have become much more acceptable and competitive in the market. So we actually have some all-flash hyperconverged, all-flash fan technologies, and all-flash direct-attached storage and servers technologies for those hot and warm buckets. And then for cold, we really think that the ISILON scale-out NAS has some critical values to Splunk that is unique in the marketplace. No matter which platform you choose from EMC, they're cost-effective and scale out because they're designed with similar paradigms to Splunk, right? You can start small and scale to many, many machines. Each of the Dell EMC platforms provide powerful data services. So if things like data at rest encryption are important, Dell EMC provides those. And then if you're using things like the indexer clustering, we have data service technologies around deduplication and compression that can help eliminate some of the overhead associated with enabling those high availability features. So this is really the kind of the encapsulation of our key value props. Now let's talk a little bit more detail about each one of these. So Dell EMC's XTREMIO is an all-flash SAN appliance that starts as small as 1 brick and scales to as many as 8 bricks in a cluster. Each of these bricks provides over 150,000 I/O at very, very low latencies. And so you can imagine for accelerating your performance around hot and warm data, all-flash technologies get very interesting. We deliver self-encrypting drives here so you can meet those encryption requirements. And then XTREMIO has inline deduplication and compression or data reduction technologies that can help eliminate some of the overhead associated with things like indexer cluster. And so XTREMIO is a very interesting platform for large-scale Splunk customers looking to have efficient hot and warm data. It's also supported by an all-flash appliance. Now, we also see a very strong trend towards software-defined storage in the marketplace. And Dell EMC actually has 2 software-defined storage platforms that are very interesting for Splunk. Both our EMC Scale I/O and VMware Virtual SAN have been proven to provide some really interesting values to Splunk environments. One of which is we provide a shared pool of storage resources across those existing servers and the existing disks and servers, allowing you to have the shared resource around performance, sharing capacity, and adding asymmetric types of storage, so having multiple tiers of storage all managed by an intelligent software subsystem. So this is a very interesting platform for those organizations really interested in a software-defined storage or data center strategy. And then, as I said, Dell EMC's ISILON is the market leader in enterprise scale-out NAS, and its value proposition for Splunk is very simple. It is a bottomless cold bucket, or nearly bottomless, I'll say. Today, ISILON scales to 68 petabytes in a single volume, single file system, single namespace. That means you can start as small as 3 nodes, scale to 144 nodes of ISILON today, allowing your Splunk cold indexes to grow in their volume without having to manage underlying file systems. ISILON does deliver data at rest encryption technologies, as well as some data reduction around clustered indexes. ISILON also has the unique value proposition of not only supporting Splunk from a cold volume perspective, but also natively providing HDFS access to the data on an ISILON cluster. Now, it's nice that we've talked about these storage technologies, and that's all well and good, but as Jenny said, we've gone this step further to actually make sure that these reference architectures meet or exceed Splunk's performance recommendations. And we've put those into documentation so that you as a customer can very simply understand what Dell EMC's technologies are, how to deploy them, and how to be successful deploying Splunk atop those technologies. Now, we certainly allow you, and many customers will choose to build their own, meaning combine some server flavor, some brand that they like, with some Dell EMC technology. But many customers really are looking for that cloud-like experience, but in an on-premise solution, right? They want the simple to deploy. They want the entire infrastructure stack to be simply managed and supported by a single organization, but they need it to be on-premise for security or compliance reasons. And that's where we really believe converged and hyper-converged technologies for Splunk get really interesting. So Dell EMC many years ago started this organization called DCE. It's now known as our converged platforms. What we've done here is we combine the best-of-breed compute network and storage into a single appliance that's logically built in the factory that allows you to deploy Splunk very, very rapidly. And as Jenny mentioned, some of the largest joint customers for Dell EMC and Splunk have adopted these technologies, again, to give them that cloud-like experience, but in an on-premise infrastructure solution. So one of the most interesting ones that's kind of in the market today that we're seeing a lot of traction and a lot of conversations is this VXRAIL hyperconverged appliance. This is a hyperconverged platform that gives you compute, network, and storage combined with that software-defined storage technology for really interesting deployment options, super flexible, super fast time to value, and proven solutions to work, providing all-flash technology to accelerate your Splunk performance. Also on the larger side, we have this concept of VXRACK, which takes advantage of EMC's Scale.io software-defined storage strategy, and this can scale to thousands of nodes in a hyperconverged platform, proven to work very effectively for Splunk. So really, Dell EMC's platforms are designed to allow you to decouple compute from storage so that as requirements change around your Splunk deployment and infrastructure, you can really respond with the right piece of infrastructure at the right time. And it wouldn't be very nice of us to tell you, hey, you should really deploy you should deploy Splunk on top of Dell EMC if we didn't in turn give you the ability to use Splunk to derive operational intelligence from those underlying platforms. So you'll find today we actually have free apps and add-ons for XTREMIO, for ISILON, and VNX, with more on the way. Those are available today in Splunkbase, and shortly you'll see a demo from Dean on these. But really the value here is that certainly we provide some out-of-the-box monitoring, reporting, and alerting based on Dell EMC best practices for storage. But this also allows you to quickly and easily onboard data from those platforms to correlate against other parts of your IT infrastructure stack. So really they give you the ability to customize those apps for your particular use case. Now, that's kind of the quick and high-level view of Dell EMC's platforms for Splunk. And what I wanted to do is give you a really quick rundown of the top 10 best practices and lessons learned that we figured out in the last a little over a year of us having a really an official relationship between Dell EMC and Splunk. And now these are candid field engineer kind of perspectives. And you can certainly visit my site, bigdatabeard.com, for some more insights. But wanted to run through these lessons learned. So number one, when you don't see us publish a best practice specific to Splunk around Dell EMC, follow the best practices that Dell EMC publishes for each of its platforms. So we publish these. They're available online and available to you at support.dellemc.com. And use these. These typically are best practices regardless of application. And then also, number two is we want you to use Splunk best practices. So we at Dell EMC really don't typically tell you to do something that is out of what Splunk would normally tell you to do. And we know that there's some things around Splunk best practices around disabling transparent huge pages and doing things like increasing U-limit because it can help with performance in a shared storage environment. And then we also noticed that hyperthreading, kind of an interesting technology, we still want to, if you're doing a virtualized environment, map physical to virtual 1-to-1 ratio for compute. But we do see that hyperthreading can help provide some additional performance in those virtualized environments. Number three, watch which levers you pull when you start deploying Splunk. If you're existing customers, you probably understand that if you change things like the volume of ingest without changing the underlying infrastructure, it can be challenging. You can create performance and capacity constraints. If you, for some reason, decided to increase the retention period of a particular index, and that wasn't accommodated in the original infrastructure design, you may create some challenges around capacity consumption faster than you expected. It's not that scaling is hard. Scaling is quite easy. But if we don't understand what is changing in the environment over time, then you can certainly create some challenges for your infrastructure. So just in general with Splunk, be aware that any levers you pull in configuration, the downstream infrastructure impacts should be considered. From a networking perspective, it is important to use dedicated fabrics. For hot and warm, we like fiber channel SAN. We see that working very well. And your cold is typically across an IP network, right? Optimizing those costs are pretty important to us. We like 10 gig. 1 gig is typically a bad idea. And we're not today a fan of converged fabrics for Splunk. So we typically like to see customers using dedicated fabrics, but definitely use as fast a network as possible anytime you are using shared storage in an application. Now, we have had a number of customers around the world deploy ISILON very successfully to support Splunk cold volumes. However, there is a known best practice within ISILON called Smart Connect Advanced. It's a technology that allows load balancing across the ISILON cluster. If you do not configure this correctly when your ISILON install, you can send all the data down a single path with an ISILON cluster, which is very bad from a performance perspective because you're not using all available resources. So if you're using ISILON and you're using it for cold, make sure you do Smart Connect Advanced correctly. And then if you're using VMware to virtualize your environment and you are planning to use XTREMIO, make sure you're using 5.5 or later from a VMware perspective. It's all about space reclamation. So we talked about some of those data reduction capabilities on XTREMIO. If you don't have these things like FSTrim and others automated, then you're not going to recognize those space-saving benefits, and so they will be a huge disappointment. I'm a Texas A&M Aggie, and Johnny Manziel represents a pretty big disappointment, I guess. Okay, number 7, existing benchmarking tools aren't very accurate when using a shared storage or virtualized environment. So if you're curious about the performance of your Splunk infrastructure, you might hear a consultant or somebody say, hey, we should use Bonnie++. And while Bonnie++ is a brute force open source tool that can kind of pound on infrastructure to see what its performance is, it isn't accurate when you're using shared storage or using a virtualized environment. And we've actually seen customers use Bonnie++ in environments where we were very certain that the performance was quite good, and it gave some very weird results that caused problems for the customer. So they weren't accurate. So if you're using a shared storage environment, understand Bonnie++ not going to be an accurate indicator of performance. And if you really want to make sure that you know performance is going to work well, trust our validated configurations. We build the technologies based on the platforms we think are interesting to Splunk. We test it with Splunk, and then Splunk allows us to publish that we meet or exceed the reference hardware performance. So you know that the joint companies, Splunk and Dell EMC, have built a platform, tested it, and proven that it will work. And so if you want to accelerate your success, this is a great thing to use our validated configurations. And definitely go install the Splunk apps from Dell EMC. Again, they're free. The apps give you this really pretty face, right? It's this nice storage reporting that is very powerful as a storage administrator, but it allows you to integrate that data very easily into your existing IT intelligence platform. So the use cases make them really awesome, so I encourage everybody to go deploy those and then start to consider how they can use them and modify them in the future. And then number 10 is call a Dell EMC Splunk Ninja. These are over 40 SEs from around the world that they know our gear, we've trained them well, but they also know Splunk. We've put them through the same training that Splunk puts their SEs through. So these are subject matter expert resources in the field that are highly trained in Splunk, highly trained in Dell EMC platforms that are there to help you and to help your account teams when you're working with both Splunk and Dell EMC. Make sure that you're using our best practices. So feel free, if you need help from one of those folks and you don't know who they are, feel free to email splunk.ninjas@emc.com, and we will certainly get you plugged in. Now, with that, I would like to turn it over to my esteemed colleague, Dean Jackson, who is going to give you guys and gals a quick demo of some of the great things we've been doing around integrating Splunk and Dell EMC. Dean?
Thank you, Cory. Again, Dean Jackson, Principal Systems Engineer at Dell EMC, coming to you from Sydney, Australia, where it is now Wednesday morning, so hello from the future. I'm going to attempt to do a bit of a live demo here and hopefully get some good questions and answers out of it. But first of all, I just want to show you quickly the Dell EMC apps that are available in Splunkbase. If you're not familiar, you can go to splunkbase.splunk.com, and this is where all the apps are held for the Splunk ecosystem. It's very, very easy to find the Dell EMC apps once you get to Splunkbase. If you go to Splunkbase and just scroll down and browse by technology, and you'll see EMC, which will soon be Dell EMC on here, and you can see all our apps. So you can see all the EMC apps, and we have quite a healthy ecosystem of apps that we have up on Splunkbase, with more to come. So one storage platforms we covered today, as Cory spoke about, was ISILON. So it's a technology add-on. So for those of you who aren't familiar with Splunk apps, technology add-ons collect from from the endpoint. So in this case, a storage platform like ISILON, and then the app would provide the visualization. So we have an ISILON TA and app, a VNX TA and app, and an XTREMIO one. Very soon, we'll see a VMAX TA being posted to Splunk base for our VMAX platform as well. So awesome, and all free to download for the Dell EMC customers out there. So that's just a little peek at Splunk base, but now let's look at a bit of a live demo. So if we want to have a look at some of these apps, I'm here in the Splunk 6.5 environment. First thing I want to show is how easy it is to collect, install and collect data from our storage platforms with these apps. So if I look at the apps installed in this environment, to install an app in Splunk is very, very easy. You can do it through GUI or through CLI. But if I have a look at, let's say, our XTREMIO app, which I have installed in this environment, how easy it is to set it up for experts. So if I look at the EMC XTREMIO add-on for Splunk Enterprise, there's a setup button here, and it just brings up a configuration view. Within there, I just put in the expert name, so whatever fully qualified name you have, and a read-only username and password. That's all you simply have to do to set up the app. Once that's done, what you'll see within your Splunk environment is a whole bunch of new data inputs. So these are inputs of how Splunk is collecting from XTREMIO. It's done via REST on most of our platforms. And here you can see all the REST endpoints from the XTREMIO platform. So, where Splunk is pulling, and you have the ability to change the polling interval and all sorts of things like that. So very, very simple. If you want to see what this looks like, we'll just pop over to the XTREMIO app. After it's set up that I just showed, you'll see however many experts that you set up in Splunk in the overview tab. I can see here, I've got 2 experts set up, amount of capacity used, those types of things that a storage administrator would be interested in. I can do some drill downs. So I'm going to go to my expert here, XTREMIO STL. And in here, I can see a great summary view of this expert. I can switch between the experts in my environment, so all good there. And see a nice summary view of performance, configurational summaries, those types of things. But let's say I was troubleshooting maybe an issue or looking for something. So I think it was Cory's number 5 best practice. Set up Smart Connect right for ISILON. Well, on XTREMIO, another common problem is customers may not set up round robin, let's say in VMWARE for multipathing. So I'm going to have a look at front end ports on my expert. So again, I'm going to do another drill down within the app. I look at a front end port, which is called target on the array. It's looking all good, but maybe I want to see all the ports at once. So I'm going to do a by performance. I'm going to do a view performance details. And I'm going to see a performance details view. Now I can switch the time view. I want to see this. And again, the cluster view. But I'm going to add in all the ports. So I'm going to add in all the fiber channel ports. I just want to look at those. So it's all pretty easy. Submit. And instantly I can see, I've got read and write IOs going on my storage platform, and I've got a fiber channel port 2 is doing 50,000 IOs on this expert, where the rest of the ports are doing a very little bit of IO. So right away as a storage administrator, I know that I have a misconfiguration there that I have to go look at. So very, very easy to diagnose issues within the environment. So that's a bit of a peek at the XTREMIO app. I want to switch over to the VNX app to show you some different views that we offer within these apps. So this is the VNX app. Again, a very similar sort of look and feel to the solution. So summary and performance views. Again, I can switch by array. So I've got a couple of VNXs in this environment. have an overview view, which shows, things like block and file storage capacity of my VNX arrays. But let's say I have a application owner complaining about performance. That maybe I'm a storage administrator and I know that that application sits on this array. I might have a peek at it. So again, I'm going to go to performance, and I'm going to go to storage processor performance, which is the controllers on the storage platform. And maybe I know it's this storage array, serial number 739. I can choose different time windows to view within this. I get a nice view here of how busy the controllers are. But I can see here that, storage controller A is pretty flat, but I've got this big workload that's started on storage controller B. So that's my first hint as a storage administrator. Maybe I've got a big workload on this. So obviously workloads are going to be generated by some sort of LUN or device on the front end. So I'm going to have a look down on the LUN performance as my next phase within Splunk to have a look at the storage platform. Again, I can choose the array I want to look at. So I'm going to look at 739. And maybe I want to look in a more tight time window. So I'm going to look in the last 4 hours instead of 24 hours. And immediately, first of all, I have a heat map here. Heat maps, for anybody who's from the storage side of the house, this is something that can, historically generate out of performance assessments of tools. This is automatically generated within Splunk. I see a heat map of all the LUNs on the array, largest box busiest in red and smallest box least busy. And right away I see there's a pesky LUN here, ASC6-test. It's doing a few thousand IOs a second within this array, so much more. If I look on the right here, I can see the list view, much more than anything else. So that's my area that I would go investigate on the storage platform. So all pretty easy, and that's within the VNX app. Now, let's say you want to take it up a level. So you're a Splunk core user, and you're maybe using these apps, and now you want to layer on and do some IT operations analytics. That's where Splunk ITSI comes in, so IT Service Intelligence. So I have IT Service Intelligence installed in this environment. It's a premium app from Splunk that you layer on top. So I have that layered with my technology add-ons from the Dell EMC ecosystem. And what I see with IT Service Intelligence is a whole view of my environment. So here I'm looking at what's called the Service Analyzer. And within the Service Analyzer, I see two very important pieces of information. First of all, I see the top services in the upper area of the window, and these are graded from worst to best, best being 100%. And I can see here right away I've got a SharePoint environment. So that's my application owner that was complaining, but it seems to be in good shape. It says 100, it's green. But I can see some other services here that are not green. So I see the overall SharePoint environment. So a service doesn't have to be a single entity. It could be a business business-driven process. So here it's the entire SharePoint environment. It's just the web front end. But it can also be pieces of hardware. So you can see here the VNX array is a service, and it's at 65%. So right away, I know that there's something going on this very same VNX array. Down below here, I can see a KPI-based view. So these are individual KPIs within the services. And again, right away, I can see that there's some challenges in this environment from the storage side. So I can see here that I've got some busy KPIs, some LUN and SP read and write throughputs that are exceeding thresholds and alerting within the environment. So again, I can very quickly determine the source. All these have drill down, so I can drill down into my VNX storage platform within ITSI. And again, this is all fed from the Dell EMC VNX TA. And right away, I can see a nice drill down view I can see the KPIs, the values of them, spark lines. It's all pretty cool. Now, let's say I wanted to if I was a service owner that I wanted to have a look at this. Well, I'm just going to show you a quick peek at Glass Tables. So I'm going to go over to Glass Tables, and I'm going to go to a SharePoint Service Glass Table. What a Glass Table is it's a view of a combined view of services or KPIs that can be tailored for anyone. And here I see a SharePoint Service Glass Table, and right away I can see that my SharePoint environment sitting on Dell Compute and EMC VNX storage. Right away I can see that the overall SharePoint Service health score is not healthy, but I know that the web front end and SQL database seem to be good. Again, it points me back to the source of my problem. So, a busy storage array in this case. Here I see, the services alerting. Now, I can do a drill down within these, and it takes me back to the same area that you saw on the service analyzer. Some cool things about the drill down that I want to show you very quickly is I can combine all the KPIs in one view, as well as I can determine which entity is causing the issue. So if I look at LUN reads throughput, I can do a lane overlay in one of these swim lanes, and I can do dynamic. And what I can see here is within the VNX LUN read throughput, I can see right away that it's LUN 30 it's doing. You can see there 8,900 IOs a second. So right away I can see the individual LUN that's causing the workload within the array, all from the swim lane view. Lastly, just to finish up, I want to show you one last glass table, which I think is pretty cool. If you're an infrastructure person, maybe you have a data center view rather than an application-centric view. I'm going to look at our Sydney Solution Center here. So small little data center for demos like this. And I can see Glass Table. It's a physical view of the IT environment. So here I see the racks, air conditioning units, those types of things within the environment. And this is a bit of a work in progress for my demo, but you can see here I can pick this rack, ASC 1-2, and I can see here that I have a service health score on that as well. And that health score, in this case, is comprised of the VNX and other things within the rack. So very quickly I can see the health from a physical view. That is it for my demo. Hopefully everybody saw something that was interesting. I'm going to hand it back to Cory for any questions and answers. Thank you.
Dean, thank you so much. It was really neat to see the integration between ITSI, Splunk Core, and how we've integrated the data coming from Dell EMC platforms. Super cool to see. Thank you so much. So the call to action for everybody on this, we'll get to questions here in just a moment, but the call to action is if you have Dell EMC technologies in your data center, and you're using Splunk Core, we highly encourage you to deploy the applications. They're free in Splunk base. The deployment is pretty simple, as Dean showed. And so we want you to start deriving value from your Dell EMC platforms using Splunk. The next is if your Splunk environment is growing or you're considering replatforming the infrastructure to support it, we highly encourage you to call your Dell EMC rep and ask him to bring in a ninja to talk about the platforms from Dell EMC that might be interesting to you. And then if you're visiting us because you're new to Splunk, then give Splunk a try. You can download it for free. You have options to deploy it locally or in the cloud, but definitely start playing with it because I think that's the fastest way to really understand the unique value that Splunk provides. So with that, I'll say thank you to everyone who attended, and then we'll open it up for questions.
Great. Thank you, Cory, Dean, and Jenny. So everyone, if you have any questions, please leave them in the Q&A panel in WebEx. This first one came in during the presentation, but this question might be for you, Cory. It says, please describe Smart Connect Advanced more. Is this unique to ISILON?
Yeah, happy to describe it. So Smart Connect Advanced is a lightweight load balancing service that allows, and it is unique to ISILON, so it allows ISILON clusters to balance the number of IP connections into an ISILON cluster. So every ISILON node has multiple IP ports, from 40 to 1 gig ports But those ports can be utilized in a number of fashions. You can balance the number of connections hitting a particular cluster based on policy. So it's a policy-based, think of it as kind of a QoS engine for balancing network connections from a host to this IP NAS. And so basically what we want to do is make sure that Smart Connect is set properly so that as Splunk indexers try to attach to the ISILON, they're not all being sent to one particular network NIC on an ISILON cluster, that they're balancing those connections across the cluster, which will give you a much better performance profile. So yeah, that's, Smart Connect is unique to us. It is a really cool differentiator for balancing connections in a clustered scale-out NAS platform.
Great. Thanks, Cory. This next one I think is for you, Jenny. This person is asking, when do you expect this Splunk VMAX app to be coming out?
Oh, great question. Thanks. So the VMAX app the VMAX add-on is in development right now, and the team at VMAX is targeting the end of Q4 to make that available. So if you have questions about that or you're interested in using that for your environment, please contact that email address, the Splunk Ninja's email address that Cory provided, and we can get you more details about that.
Yeah, I'd also encourage you to go out and check out the site, because as soon as we, the Dell EMC site on Splunk, we'll be posting those links, and then also check back in Splunk Base. As Dean showed you, there's a See All EMC Apps option within Splunk Base, so be sure and check back there towards the end of this year, and we're hoping to get it out by then.
Cool. Thank you, guys. The next question I have here is, what is the difference between an app and an add-on? I think both were sort of shown in the demo there.
Yeah, so I can take that. So add-ons and apps are very similar, but primarily an add-on is intended to collect data from sources, perform the field extractions, and do any other kind of work like calculations or conforming the data to our common information model so it can be used with other applications like enterprise security and ITSI. An app is typically the combination of searches and reports to provide an initial visualization for folks to get started with, and it's also a great starting point to customize. You can look at that and say, okay, I like this report, but I'd like it to have this information, or I'd like it to be modified slightly. You can go in and go ahead and modify those apps to your liking.
Cool. Thanks, Jenny. This next question is, where can I get a copy of the reference architecture that you guys mentioned earlier?
Yeah, so the best page, the easiest page is the Splunk.com/Dell EMC. I believe all of those are posted there. That's probably the best place to go, and that we're kind of using as a convergence location. You can also use this, there's this powerful tool, I think people refer to it as Google, that you can actually just type in Dell EMC reference architecture for Splunk, and you'll get a number of the PDFs kind of hosted internally for us. But yeah, Google's an easy way to find them. If not, then Splunk.com/Dell EMC.
Cool. Thanks, Cory. This next question is, are there Splunk apps for converged infrastructure like vBlock and VXRACK?
So there's not today, so I'll take that one. There's not today, but there, like every organization, we are currently reviewing what applications need to be developed, what investments need to be made, and what values customers would want to see from those applications. So I highly encourage that if you're a user today of Splunk and you have those platforms and you would really like to see those applications, again, use that email address, splunk.ninjas@emc.com. I apologize, it's not a Dell EMC. We're doing some internal updating of those things internally, but splunk.ninjas@dellemc.com, and we'll certainly get that information, especially as it comes from customers asking for it. It's very valuable to us. So we appreciate the feedback. If you find them interesting, let us know, and we'll certainly add that to the lobby for support for development.
Cool. Thank you. This next question is, where can I learn more about these Splunk Ninjas beyond what was discussed in this webcast?
The easiest place is go to bigdatabeard.com, and you'll see the output of a lot of these Splunk Ninjas and a description of what some of those folks do. But you can also you can contact me via that Splunk.ninjas at emc.com, and I am most happy to discuss with any of you about what that team is, what the program is, the kinds of training and certification that we've put those folks through. But really, that team is, for us, it's just a response where we saw customers in the field wanting help. As Jenny said, they wanted help deploying the right infrastructure to make Splunk work well. And we realized that our most trusted resources to our customers is oftentimes our pre-sales engineers. And so we took a handful of the best pre-sales engineers from around the world and gave them that additional Splunk training for the expressed intention of responding and helping customers be successful with their Splunk deployments on Dell EMC. So they've been put through, as I said, the same SE-type training that the Splunk team uses internally for their own SEs, and they're continuing to get some additional training throughout the years. Many of them have taken certifications as by folks like Dean leading the way, all the way through ITSI to Splunk has a big data certification that they're working out that a handful of the team has taken. So really interesting certifications, and they're really there, again, to help support customers being successful deploying Splunk on Dell EMC.
Great. Thanks, Cory. So I don't see any more questions coming in right now, so why don't we go ahead and wrap up. Thank you, everyone, so much for attending today. I'll be sending out a follow-up email within the next couple of days containing a link to this webinar recording along with some other resources. But again, thanks for attending, and have a great day.